This is 6.3, day 1. We're going to split this section up into 2 sections. Today's lesson is going to focus on long division. This is a brand new topic for you in Algebra 2. You've not seen it in Algebra 1. And then tomorrow's lesson will be 6.3, day 2, where we focus on polynomials with synthetic division. So this first example does seem a little bit elementary. It is what we taught you in elementary school, but it's going to lead into what we're going to do today. So you may just want to watch on this first example. So in elementary school, we did a lot of division where we say, okay, how do you take 161 and divide it by 7? Remember, that numerator is going to go underneath. And then the denominator is what you're dividing into. So now we look at, does 7 divide into 1? No. So then we go to the next placeholder, and we say, does 7 go into 16? Yes. It goes in 2 times. So we put the 2 above the 16. And now what we do is we multiply 2 times 7, which is 14. And then remember what we did next is we would subtract those. So 16 minus 14 is 2. And then what we did next is we would bring down this next place, which is 21 now. Because 2 cannot go in, or 7 cannot go into 2. So now we say, does 7 go into 21? Yes. It goes in 3 times. And now we multiply. 7 times 3 is 21. Now we subtract, be very careful, and we get 0. Our remainder is 0. So our answer then is 161 divided by 7 equals 23. We're going to do one more of these and then move on to what our problems will look like today. A little bit bigger number. So again, the 5,643 goes inside, and then the 12 goes out in front. I'm just going to erase those arrows. Again, you do not need to write this problem down if you don't want to. All right, so now we look at, does 12 go into 5? No. Does 12 go into 56? So you think about 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48. If I go above that, then I've gotten to be too big of a number. So it goes in 4 times. Now remember again, I multiply. So 4 times 2 is 8. 4 times 1 is 4. So I get 48. And we subtract. So I'm going to carry the 6 with that 1, and now this reduces down to a 4. 16 minus 8 is 8. Now I bring down that next place to make it 84. And I say, does 12 go into 84? Yes. 7 times. So I multiply. 7 times 2 is 14. Carry the 1. 7 times 1 is 8. 84. Subtract. I get 0. Then I bring down that last placeholder, 3. Does 12 go into 3? No. This is considered a remainder. So my answer then would be 5,643 divided by 12 equals 47, remainder 3. All right, this next example you do need to write down. What we want to do is use long division to factor. We have a polynomial, it's a cubic polynomial, and we want to divide out x minus 2. So remember, what you're dividing by goes out in front, and then your numerator goes underneath. So please make sure you're writing this problem down. All right, so we are taking a polynomial and dividing it into another polynomial. So here's where it gets to be a little tricky. You focus on the polynomial underneath, and you want to make sure you have all of your terms in descending order. So I have an x cubed, then I have to have an x squared, an x, and a constant, which I do. There will be a problem later where there might not be a placeholder there, so we just add in like a 0x squared or a 0x. That'll make more sense when we get to one of those examples. So here's what we do. We look at the first two terms, the term out in front and the term underneath. So I'm just going to focus on x and 6x cubed. And I want to say, how many times does x divide into 6x cubed? So I'm going to do this step over on the side. So I'm going to say, how many times does 6x go into 6x cubed? So just divide it and say, 6x cubed divided by x, I can reduce that by an x. So I'm left with 6x squared. So that is what goes up on top, 6x squared. Now remember from long division, I multiply that 6x squared to both pieces. So I take 6x squared and I multiply it by x, and I get 6x cubed. Then I multiply 6x squared times -2, which is -12x squared. Now I throw a line underneath it, and this is where you have to be very careful. The most common mistake in long division is this. We have to subtract this polynomial, 6x cubed minus 12x squared. So when I subtract it, I'm subtracting the whole polynomial. So I have to essentially change the signs. So I subtract, well this already is a subtract, so I have to change it to a plus. And now I say 6x cubed minus 6x cubed is 0. And then -19x squared plus 12x squared is -7x squared. Now I'm going to go ahead and bring down the next term, plus 16x. Now I focus on the first two terms, x and -7x squared. How many times does x divide into -7x squared? So I'm going to write that off to the side. -7x squared divided by x. Well, I can reduce that by an x, so I'm left with -7x. So that was what's up on top. And now I multiply again what's out in front. So -7x squared multiplies to x. So I get -7x squared. Then I take -7x times -2 is positive 14x. Make my line. And now the next step is I have to subtract. So I'm subtracting through. So this becomes a plus. This becomes a minus. Always change the signs like we did in long division in elementary school. So -7x squared plus 7x squared becomes 0. And then 16x minus 14x is 2x. Now I'm going to bring down the last term, -4. All right, I'm going to focus on the first term again. How many times does x divide into 2x? So I'm just going to write it off to the side. 2x divided by x is, the x's will cancel, and I'm left with 2. So that's going to go up on top. I'm going to just erase those green arrows. Now I multiply positive 2 to x, which is 2x, and then positive 2 times -2, which is -4. the line underneath it. And now I make sure I change my signs. I'm subtracting through. So subtract, well this already is a subtract, so I change it to a plus. 2x minus 2x is 0. Negative 4 plus 4 is 0. What I got is a remainder of 0. So this tells me it is factorable. So my answer then is right here. So 6x cubed minus 19x squared plus 16x minus 4. Dividing it by x minus 2 is going to give me this as my answer.